So, area between two polar curves, and this requires major attention to detail. It's beyond what we already did, because it builds up. All right, so what does R equal? I think I have R equal 2 on your graph, yeah? Okay, so what does R equals 2 look like? Circle centered at the origin, yay? And if you have colors, sometimes a little color is handy here. R equals 4 is also a circle, but centered at the 2, yeah? Okay, so something like that, yay? Now, in this one graph, there are actually typically 3 problems they could ask you. They could ask, A, find the area inside R2, outside R1. Now, inside R2 means inside the cosine circle, but outside R2 means outside the origin circle. So, if you remember, polar area is not rectangles, it's spokes. Okay, sectors. Polar area is sector-based, not rectangle-based. So draw some shade of sectors. You got it? Alrighty then. Now, each of these areas is, think of it like if you took the sector all the way out to the red, but then removed this part, yeah? So each sector, area between, is, in essence then, the difference between two areas, the outer minus the inner. Now that's different than rectangular, which we did upper minus lower and right minus left. In polar, it's outer minus inner. Greater R minus lesser R. And we're still going to use symmetry when possible. So in this case, I have symmetry going on. I could do the upper half open. So let's talk about this. I'm going to do 2 times. Now, I don't need to make this. Actually, I should have done one better. I don't need to do this in 2 integrals. I can put it together in one. We know integrals added and subtracted can be either put together or separated out, and it helps to put them together. You follow? Mm-hmm. Okay, so we're going to do 2 times a half, and we're going to we'll talk the limits in a minute, but outer minus inner, remember it's squares for the formula, R squared each time. So, what's the outer? 4 cosine of theta. And what's the inner? 2. Okay, so that's the integration. Are we good so far? Now the bounds. Because I'm using symmetry, where's the start of the region? Where is the start of the region? 0. Excellent. How do I find the end of the region? Where they cross, where they intersect. End at the intersection. So that'll be a lot like rectangular. When we have area between 2 curves, we need to find the intersection point. Same goes here. So when 2 equals 4 cosine theta, or when cosine theta is a half, and where is cosine equal to a half? Pi over 3. Okay? Would you throw that into your calculator? This is going to have some calculator components too. Do-do-do. Okay. What did I say was outer cosine? 4. Oh, start 4. 4.
No, before inside the cosine.
Yeah, make sure you're careful with the parentheses.
652.
I'm using theta, but I guess I don't really need to use theta. I could use x. It would be the same, honestly. Did you get 7.653-ish? Okay. So this is roughly 7.653. Going so good? So far so good? Okay, cool. Let's go to the next one. Now, the area inside R1 and outside R2. So if you inside R1, outside R2. Okay. So when I say inside R1, that's inside the blue on my graph and outside the red. So starting at 0 until I can get to some points, I start to get shade here, yeah? All right. You down? Okay. So, let's go here. Let's use symmetry and just do the upper part. Are we cool? So, let's get going. 2 times a half. All right. I have an integral. From where to where? Pi over 3 to pi. Okay, write that lightly. Okay. What is the integrand? Outer minus inner. 4 minus 4 cosine theta squared. We or no? Okay, so here I agree. I only want this chunk, so I'll definitely have to do outer minus inner. Yeah. Definitely need to do outer minus inner. Outer minus inner. Okay, but now here, do I need to do outer minus inner then? So, because it's got 2 situations, I must use 2 integrals. All right, so it is not going to go from pi over 3 to pi. It'll go from pi over 3 to the end of this region, and that is indeed pi over 2. This little yellow region is only to pi over 2. Very cool. And then we're going to add the green region, which is from, oops, sorry, it has a 1/2, from pi over 2 to pi of outer minus center or just straight up normal polar areas? Straight up normal polar area. Do I even need to use, I'm using an integral and I should, 2 squared d theta. Could I do the left side of the graph geometrically? Yeah, how? Pi r squared, either quarter pi r squared in the parentheses or half pi r squared if it wasn't in the parentheses, or you could use geometry. Find the area, please. Exchanging glances. I'm just gonna scratch the 2.5 and wondering in the night, what were the chances we'd be sharing love before the night was through? So is this outer minus inner? Yes. What's the outer again? It's the same, yes. Not. Oh, dang it. Oh, dang it. Got zzz. Did you get, well, that's not right. Oh, I didn't add in the half circle, yeah? Plus 2 pi. Okay, did you get something like 7.653 again? It is. How is that the same? Yeah, really, it's the same shape if you look at it. Okay. All right, cool. Now let's do one more. 2. 2. Okay. Now, inside both. Now, when I say inside both, I mean every point has to be inside both, not inside either, inside both. So that's this region here. Would you agree that all those points are in the overlap, inside both? You down? Okay. So, get me started here, people. Can we use symmetry? Yes. 2 times a half of an integral from 0 to pi over 2. One integral? Okay. Now this is where a big picture is super handy. And in fact, on the test, if you feel like you're not getting the big picture, then draw it really large. Ask for extra paper. But say I drew sectors. Do you agree that there's no outer minus inner? I'm just going to the green curve here, right? Until I get to this point. Now, when I get to that point, am I going to go to the green anymore, or now am I going to go to the red? So how many regions? 2. There must be 2 regions. Region 2 and region 1. All right, so it is subtle, especially region 2, but 0 to pi over 3 of what squared? 4 cosine theta, or just 2? Just 2 in that region, yeah? And there's no outer minus inner component. Minus a half from pi over 3 to, when does that little tiny thin wedge end? Pi over 2. And what's the integrand? 4 cosine theta. Okay? I assume with time you could put that in your calculator, so it's not going to be saying, believe me, they don't always come out 7.653. Okay? Let's go to a little different situation. What does r equals 2 plus sine theta look like? It is a limaçon. Where do the r's go as you go from 0 on around at the angle, at the axis? 2, 3, 2, 1. Does it have a dimple? It is just on the edge of dimple, but it is not dimpled. It is egg-shaped. Okay? And 4 cosine theta is the same as we had before. Okie dokie. So we got that kind of situation, yeah? All right, would you shade with spokes or sectors inside R2, outside R1? Alrighty then. Now this is calculator active. So, will this be 1 or 2? 1. And outer minus inner, what's the outer? 4 cosine theta, and the inner is 2 plus sine. Symmetry, yay or nay? Yes, no? No symmetry. Okay, so we're going to need one big old integral, and you say outer minus inner is 4 cosine theta minus 2 plus sine theta. Don't forget your squares, obviously. And the last thing to be determined is the intersection point. You with me? Okay, so if, I will show you this here. If you are in polar, like I am, and you go to find intersection points, your calculator says niet. If you try and do intersection points, it says graph, and I'll say this one, or this one, and this one, and it is a big fat nope. Will not find intersection points in polar mode. So what's the workaround? That's not clean trig. We're not going to do that by hand. Yeah, just graph in regular mode and find the intersection points. And it's a bit of a workaround, but it is what it is. So graph normal. Now my graph's going to be a mess, but oh well. 2 plus sine theta. X, actually. Now it's going to be x. Oh, shucks. So here's the deal. You should be able to do the homework. Tomorrow we'll go over both 129 and 128x practice. The key is online. Yesterday, 128x practice key is online. So you can check the work. And that's all. Have a lovely day. For yesterday? Yes. I didn't, oh, that's right. Yes, it was just a. Just yesterday? Yeah.
I like,
Yeah,
like,
yeah, we got to do 127 and 128.
so there is this one, where's the one? And I was going, and I was like, slowing down, and then I wouldn't stop in time, so it started and then the page started taking, and it's never gonna go away. I have to go back to the screen to your point. I have to yes. I know I'm not, but it's like every time you I had to revise it back and like
That was pretty archaic.
oh yeah, I mean this group is good, they just radiate
All right. Don't rush Gary. Or Gary. Let's see. He does? He's hurrying so hard for you. Cut him some slack, Ben. All right. Thank you. Have a great day. See ya.
Help with this since you're doing
Okay.
number 10. I just don't know where to go from there.
Oh yeah.
Is that right?
Yeah.
That point?
Yeah, you did. You could do direct comparisons, that still might be easier. That's it, so you could do that. I would also say that you can integrate this by inverse tangent. If you divide it out of half, it's this kind of deal.
X over, and then would it be inverse tangent of x over 2?
Root 2, because u squared is x over 2, so it'd be x squared over 2, u is x over root 2.
Do we need anything in the number?
Oh, you're right. So du would be 1 over root 2 dx, so it would be root 2 over. So it would be 3 root 2 over 2 arctangent of x over root 2.
And then that would,
That'll
yeah,
it should convert
as it goes.
because arctangent.
So either way, direct comparison test, does that get you started?
Yeah.
Okay.
I
You
just need to
don't,
finish the one.
you don't need to finish,
Okay.
if you understand.
Yeah.
Hi.
Quickly, do you have an extra copy of tonight's set?
Actually, make one extra copy and just section of it.
And will we be meeting here?
Yes.
And Cindy and I do have a meeting next Tuesday, so we'll
Okay.
need to know that.
Okay, I will.
The committee has to figure out and agree on all of the questions and all of the stuff that we're talking about today. The whole committee has to agree on next week.
Okay. Hi.
I did not know this was a spirit day today.
Thursday, do I? Thursdays, what's Thursday? I actually do have Thursdays. Thursday. Here's Friday. And oh, State, you must be really close.
I promise there's only one more of these.
You're not gonna have all world or all country, all nationals. Okay. You're welcome. Hi, B. I will probably work till 4:30, go to the gym till about 5:45, or 5:40.
Who's making dinner?
Probably me and your mom, we're gonna probably.
Jeremy Recorder, please report to attendance. Jeremy Recorder, please report to attendance.
Well, I can make dinner. I have math and instrument, so I don't have that much.
Go to the gym. We'll meet you at the gym.
I don't go to my grandma.
Oh. You could go to the gym and go to town.
Because I don't want to have to go out again. Otherwise.
Suit yourself. Well, anyway, that's the plan. I'm thinking 5:45.
Okay, so if I have dinner ready by
6 would be safe.
oh, I don't know. Do we have potatoes?
No, we need to go get them. Bye. Okay.
That's like the most important, it's like the coolest thing for that. You're gonna be like that? You should respect that those kids are.
All right.
It's not asserting dominance to say that you have no respect for others.
All right, exit